The next exercise that we will look at in the demo exercises is number 6, and this is a Flowsheet Configuration Change. When you have a flowsheet, it is possible to direct streams to other equipment pieces. This is common in the flotation circuit especially. When this happens, you have a choice whether you want to delete streams in this flow sheet and redirect them to other equipment pieces, or you can have a splitter where you can direct zero flow to one side and all the flow to the other side. This is the easiest way to simulate flowsheet configuration changes. So in the exercise, we are asking, what will happen if the product of the recirculating crusher is directed to the secondary ball mills instead of back to the sag mill? In the current plant configuration, 50% of the crusher is sent back to the sag mill. So what will happen if 100% of the pebbles are sent back to the secondary circuit? So if I click on the splitter, I can say how much do I want to send to the left back to the sag mill, and I'm choosing 0. Let's see what happens if I do this. I will have problems in my sag mill and my crusher, but the secondary circuit will still behave in a good way. What is happening to the sag mill? The total filling has gone red, so the total filling is low again. So this was to be expected when you don't send pebbles back into the sag mill. You would expect the total filling to drop. So again, we would have to consider changing the probably the mill speed, because that's the easiest variable to change in order to increase the filling inside the mill. And this is done to protect the liners. And again, we still have the same problem in the crusher, and that is that we are reducing too much. So it is possible that this closed side setting in our simulation is a bit too low for this specific scenario. We can see in the ball mill that we have good operation. The icon is blue, so there is our power draw, and in the graph you can see that our real power draw is smaller than the installed motor power. In our cyclone, you can see that we have quite an effective operation here with our percent solids within ranges and our P80 of 144 micron. Okay. There are some errors in the flotation, but we will address that later on in the demo exercises.